Greetings to you all. I welcome you back to this channel. My name is Joshua. I'm going to take you through chemistry, and we were looking at group 7, and I want us to continue with the periodic trends of group 7 like we were doing last time. So this is periodic trends number 2, and that's going to be the last when it comes to the periodic trends of group 7. Allow me share some few slides, and we shall be seeing where we are supposed to be focusing. There we are. So remember last time we were trying to look at electron affinity, bond energy. We're looking at the melting points and boiling points and other things. So today we're starting with the electrode potential. That is our number 5. Electrode potential, the reduction in the electrode potential usually becomes less positive. Less positive. I repeat, less what? Positive down the group. Therefore, it means that fluorine is the most powerful oxidizing agent. Last time I told that the more positive an element is, the more oxidizing it is. And the more negative, the more reducing it is. The most negative electrode potential represents the strongest reducing agent. And the most positive electrode potential, of course, represents the strongest oxidizing agent, like I'm already saying. Okay, now we look at electronegativity. Chlorine 4, chlorine, we have 3, bromine is 2.8, then iodine is 2.5. So generally, you can easily tell that the electronegativity is decreasing generally down the group from chlorine down to iodine. So, why? Concerning any group in the periodic table, but this time we are specifying looking at group 7. The screening effect of the inner complete shells of electrons outweigh the increase in the nuclear charge. Of course, because there is always an extra filled shell that is added. You know that very well. So the effective nuclear charge decreases. As such, the attraction of electrons in the covalent bond, of course, decreases, leading to decrease in electronegativity. So you're going to check through properly and see what we're going to do. You sit down and listen yourself and try to understand that statement. Why is the fluorine a high oxidizing agent? One, it has got very low bond association energy. You can know that when we're trying to look at bond association energy, we saw that it has abnormally low bond association energy. And because of that particular reason, it means that its bond can easily break. If it can easily break, it means it can easily bond with anything else. And that shows that it can easily oxidize other substances, because we've already said that it's an oxidizing agent. High enthalpy of hydration, absence of enthalpy of fusion and vaporization. So all those ones, it doesn't have enthalpy of fusion, that is maybe formation of ice or evaporation. No, there is nothing like that. So those are the reasons why we expect actually fluorine to be a strong oxidizing agent. The reason is why iodine now is a weak oxidizing agent. So we are looking at the opposite. It has a weak II bond. So that covalent bond is weak. But because it is a solid, it requires high enthalpy of fusion and vaporization. So it having a weak covalent bond would be actually helping it to be a strong oxidizing agent. But because for it is a solid, it requires high enthalpy of fusion and vaporization. Fluorine is always univalent. Why? Because it doesn't have the vacant d orbitals. Doesn't have for it. So when you write its configuration, you find that it's going to be 1s2, 2s2, and then 2p5. So it doesn't have any d orbitals, but all other elements of group what? Of this group 7 have got empty d orbitals. So those orbitals have a very big role in accommodating many other substances, which actually fluorine cannot do. So the other d orbitals allow them to expand their octet, but you know very well that for fluorine it doesn't. So we say that other elements can show higher oxidation states due to availability of the vacant d orbitals, which allow them to expand their octet. So those vacant d orbitals are the ones which accommodate the incoming electrons from other different substances. That's what we call expansion of the oxidation what? State. Fluorine behaves differently from the rest of the members. Why? It has got a very high electronegativity to very small atomic radius, and we've already seen why those things actually affect the different reactions, affect the bond energy, affect all different other factors. A low bond energy, we've known that already, and it has got a very high positive electrode what? Potential. Because if I just say high, maybe you may think that I mean high, which is in negative. No, this time I mean high, which is positive. The more positive you are, of course, the more oxidizing you are. So for it to behave different because its electrode potential is extremely high as compared to other members of group 7. Special properties of fluorine, which indicate how it behaves differently. So let's look at those few and we move. It combines directly with carbon at room temperature, which others don't. You know, it forms carbon tetrafluoride. Hydrogen fluoride has a very high boiling point, and of course, the reason is because it can form hydrogen bonding. That one is in bonding, like I'm going to be sharing with you now bonding later on. Hydrofluoric acid is the weakest acid compared to other halogen acids. You know very well, it's the only weak acid. All other acids, the halic acids, all of them are strong. Look at HCl. HCl is strong. pH1, we have HBr stronger than actually HCl, and HI actually stronger than all others. But for hydrofluoric acid, for it is weak. So it has got at least an anomalous behavior there. Okay. There are some questions which usually come along and we must be knowing them. Silver fluoride is soluble in water. While the chloride, the bromide, and the iodide of silver are instead insoluble in water. Why should that one happen? This is because the small fluoride ions have high hydration energy, which actually exceeds the lattice energy, and so the enthalpy of solution becomes very negative. This one is in thermochemistry, and those are the topics that we're going to be covering. I'll always try to explain those particular areas to help us even understand them better. But we've already shown that one of the anomalous behaviors of fluorine is that its silver fluoride is soluble in water. But surprisingly, the silver chloride, the silver bromide, and the silver iodide are not soluble in water. So if I'm to confirm a chloride, a bromide, and the iodide, I can actually use silver ions. I mix and I get a precipitate, either white, a yellow, of course, bright yellow. But for silver, nothing will happen because for the fluoride, nothing will happen because silver does not precipitate with the fluoride. So we know that very well now. Okay, fluorine has only one oxidation state. We've already talked about that. And to test you, explain briefly why. Why did we say? So I think you remember about the electron configuration. how different is fluorine from other elements. So use that kind of information and try to explain to yourself. I think I started with that statement when I was talking about fluorine in particular. Fluorine does not form oxoacids. It doesn't. For it has only one acid, and that is HF. These oxoacids, which are having oxygen in them, it doesn't do what? Form them. It doesn't. So it is special. Calcium fluoride, I think that statement is supposed to be fluoride, not fluorine. Let me try to edit that. Calcium fluoride. I mean calcium fluoride, not calcium fluorine. This statement should be corrected. Is insoluble in water, while other halides are soluble in water. Explain why. We look at steel, the lattice, because all of them are ionic. So you focus on that and try to explain to yourself. You can comment you can comment below, and then we see how you're explaining that. If then I can respond to you accordingly. But we're trying to look at these questions which are testing our brains, looking at the thermochemistry and the many other factors that affect the group 7. For now, I want to stop there, and I want to wish you the best. So the next time, we shall move on to look at even other factors after explaining those particular few concepts. Don't forget to subscribe to my YouTube channel, Tumine Joshua, and like what we are doing. You can comment and give us advice where we have to improve, and then we shall actually improve. All right. Here we are. For now, allow me to stop here, and I wish you the best.